Hello learner, welcome once again to Manifested e-learning platform. My name is James Kenyani. We are going to proceed with our topic on reflection and congruence. And in today's lesson, we are going to go through geometrical deductions using reflection. And in our lesson today, we shall look at reflection in a point and vertically opposite angles. So, the lesson. So, as I've said, under the geometrical deductions, we are going to look at reflection in a point and vertically opposite angles. So, at the end of the lesson, the learner should be able to understand the relationship of reflecting through a point and what it has to do with vertically opposite angles. So as the objective goes, we are going to get the relationship we get when we reflect 2 points, 2 points in a point. So the first step we can reflect. We can look at reflecting a point in a point O. Reflecting a point in a point O. Correct? So we start building the relationship from one point. So let's say we have that point O, and I have A. I want to reflect A through point O. This is what we shall get. This is what we shall get. Distance, we've been saying distance of the object, same as distance of the image. So O is the reflecting point. So this is what we shall get. This is what we get. So if I have A prime, there is a relationship we get. There is a relationship we get. It's like, this is the same as rotating this point through 180 degrees, or we call it a half turn. So reflecting through a point is like a rotation of 180 degrees through the point, a rotation of 180 degrees, or a half turn, a half turn. It is like a rotation of 180 degrees, and realize that this image, this object distance is the same as image distance, and line A or A prime, line or line A or A prime is a straight line. A straight line learner is a straight line. It is a straight line. That point should sink into your head. Reflecting through a point is like a half turn or rotation of 180 degrees. So to understand what was the objective of the lesson, we shall consider rotating. We shall consider rotating, reflecting, not rotating, reflecting 2 points. What do we get? Reflecting 2 points through O. Reflecting 3 points in A. So you always write in A. When you reflect, you say in A, in O. Reflecting 2 points in O. So I'm going to have 2 points A. A is here. I have another point B. I still have to reflect them through point O. I'm going to reflect them through point O. What am I going to get? From the first relationship, we get a line joining A, O, and the image A prime is a straight line. So without much of I'll draw that. So I'll get A prime. This distance and that one is the same. The same will happen to B. Straight line. B prime. So you realize I get a series of angles. I can call them A, angle B, angle C, and angle D. So you realize A, O, and A prime are straight lines. They are straight lines. So we shall move and explain something there. What deduction do we get when we reflect 2 points in a point? We get a series of vertically opposite angles. So we shall prove. We know A plus B from the diagram. From that diagram, we realize A and B, because they lie on a straight line, it will give us what? It will give us 180 degrees. A plus B gives us 180 degrees. That's correct. Also, B plus C is equal to 180 degrees, which means if we take the first equation and we have the second equation from that diagram, because it is true, they lie on a straight line. Therefore, they should be equal. So from that, equating the right, equating 1 and 2. What shall we get? If we equate 1 and 2, Lana, what do we get? We say A plus B is equal to B plus C. But B and B are there. Therefore, from that, we get B is equal to A plus B. A, we shall get A is equal to C. Sorry, we shall get A is equal to C. This angle and this one will be equal to that, and they are vertically opposite angles. We can also use this one, DB, also BC B plus C is equal to 180. That's correct. And then C plus D is also equal to 180. We can then equate this and this. So this first one and the second one, we shall get B plus C is equal to C plus D. Since we have CC, it will mean also B will be equal to D. So what deduction do we get? Because that is what we want to get to know. When we reflect 2 points in a point, we get vertically opposite angles. We get vertically opposite angles when we reflect. When we reflect 2 points in a point, Lana, we get two pairs of vertically opposite angles equal, each pair having equal angles. Each pair having equal angles. Each pair having equal angles. That has already been proven. We proved that from that. Reflecting 2 points in a point, we get a geometric deduction. We get 2 pairs of vertically opposite angles. B and D are vertically opposite angles, and each pair having equal angles. Each pair having equal angles. So we go through what we wanted. We wanted to get that deduction of reflection in a point and vertically opposite angles. So to get that, we use 2 points, A and B. Reflecting A, we got that straight line. Reflecting B through in L, we got that. And that brought us to 2 pairs of vertically opposite angles. This is proving that they are equal to each other. So Lana, having met that objective in the assignment, So in this case, you can choose your O to be anywhere and A and C to be anywhere. It's not particular. I've not given a particular position. You will reflect points C and D in O and prove that the vertically opposite angles found are equal. So go through that as you build up on deductions we can get using reflection. So thank you for your audience and work out the solution to enjoy the topic. So at that end, have a good time and let's meet in the next lesson. Thank you.